Tonight, we are going to talk about something you are doing right now, even if you feel completely still. You may be sitting in a quiet room, lying in bed, or watching this screen while the floor beneath you feels solid and unmoving. But that stillness is only an illusion created by perspective. Earth is spinning beneath you. At the same time, it is racing around the sun. The sun is carrying the entire solar system through the Milky Way, and the Milky Way itself is moving through space with other galaxies around it. Nothing is truly resting. Everything is moving compared to something else. A person can feel still on Earth only because the room, the air, the ground, and the planet are all moving together. But when we zoom out, the stillness disappears. There is no cosmic floor, no perfect center, no final place where all motion stops, only motion inside larger motion. So tonight, the question is simple. Why is nothing in the universe ever still? Before we begin tonight's journey, subscribe to the channel if you want more calm space documentaries like this. Leave a like if you enjoy deep space mysteries, and write in the comments where you are watching from and what time it is where you are right now. Tonight, you are watching the Space for Sleep channel, talking about why is nothing in the universe ever still? To begin answering that question, we have to start with the most convincing illusion you experience every day. Stillness. You can sit in a chair, place your feet on the floor, and feel as if nothing is happening. The room feels fixed around you. The walls stay where they are. The air does not seem to rush past your face. A cup on the table does not slide away. Your body does not feel like it is being thrown across space. Everything feels calm. Everything feels stable. Everything feels still. But this feeling is not proof that you are motionless. It is only proof that you are moving with everything around you. The chair, the floor, the building, the air, the city, the ocean, the mountains, and the entire planet are all sharing nearly the same motion. Because everything nearby is moving together, your body has nothing close by to compare against. That is why stillness feels real. It is not because motion has stopped. It is because the motion is shared. If you are inside a smooth airplane flying high above the clouds, you can feel almost still in your seat. A drink can rest on a tray. A person can walk down the aisle. The cabin feels like a quiet room. But from the outside, the airplane is racing across the sky. The stillness inside the cabin is not false exactly. It is real from your local point of view. But it is incomplete. The same thing is happening on Earth. You feel still because you are inside the moving system. You are not watching Earth from the outside. You are being carried by it. This is one of the first strange lessons of the universe. Motion depends on perspective. There is no simple feeling inside your body that tells you your true cosmic speed. Your senses are made for nearby changes. They notice when a car brakes, when an elevator starts moving, when a boat rocks, when the ground shakes, or when wind pushes against you. But steady motion can disappear from experience. You usually feel acceleration, not constant motion. That is why Earth can carry you through space without your body noticing. Right now, the planet beneath you is not resting. It is turning. Every point on Earth is being carried around the planet's axis. If you are near the equator, the surface is moving extremely fast because it has to travel the widest circle in one day. Farther north or south, the speed is smaller, but the motion is still there. The entire planet is rotating, and we rotate with it. But because the atmosphere rotates with Earth, and because everything around you shares that motion, the surface does not feel like a giant spinning object. It feels like ground. That is the illusion. Ground feels like the opposite of motion, even when it is part of motion. This is why a calm room can be misleading. The quietest place you can imagine is still moving with Earth's rotation. A silent bedroom at night is not separate from the planet. It is attached to a spinning world. The bed, the walls, the ceiling, the air, and your body are all carried together around Earth's axis. Nothing in the room needs to look dramatic for the motion to be real. The motion is hidden because it belongs to everything. And Earth's rotation is only the first layer. The planet is also moving around the sun. Earth is not parked in space while it turns. It is traveling along a path around our star, completing one orbit every year. That motion is much faster than the rotation we feel locally. The entire Earth, including every person on it, is constantly falling around the sun in a curved path shaped by gravity. This is a difficult idea because the word falling usually means moving downward. But in space, falling can mean orbiting. Earth is always falling towards the sun, but it also has enough sideways motion that it keeps missing. Instead of dropping straight into the sun, it follows a continuous curved path. The planet is not sitting on a track. It is in motion, held by gravity, and carried by its own forward speed. So even if you feel still in a quiet room, you are on a spinning planet that is also falling around a star. And the story does not stop there. The sun is moving too. The sun is not the fixed center of the universe. It is only the center of the solar system. The entire solar system is traveling through the Milky Way, carried by the sun's motion around the galaxy. The planets do not orbit a star that is standing still in a dark room. They orbit a star that is itself moving through a vast galactic structure. This means the solar system is more like a moving family than a stationary model. The planets circle the sun, but the sun is also carrying them forward through the galaxy. Earth's path is not a simple flat circle in a frozen background. It is part of a much larger motion, layered on top of other motions. A spinning planet, orbiting a moving star, inside a moving galaxy. This is why stillness begins to fall apart when we zoom out. At small scales, you can define stillness. Locally, a book can be still on a table. A person can sit still in a chair. A house can stand still on the ground. These descriptions work for everyday life because they compare objects to their immediate surroundings. But when we ask whether anything is truly still in the universe, the answer becomes much harder. Still, compared to what? Compared to the room, you may be still. Compared to Earth's center, you are rotating. Compared to the sun, Earth is orbiting. Compared to the Milky Way, the sun is moving. Compared to other galaxies, the Milky Way is moving too. Every time we choose a larger frame, the stillness changes. This does not mean everyday stillness is useless. It is useful because human life happens locally. If your phone is on a desk and does not move relative to the desk, it is fair to say it is still. If a mountain does not move relative to the ground around it, it is fair to say the mountain is still. But these are local truths. They are not final cosmic truths. The universe does not give us one obvious flaw. There is no universal room where everything can be measured against perfectly. There is no giant grid in space with a sign that says this is the true rest point. Motion is always measured relative to something. That is what makes the feeling of stillness so strange. It is both real and incomplete. You really may be still relative to your chair. But the chair is moving with Earth. Earth is moving around the sun. The sun is moving through the galaxy. The galaxy is moving in a larger cosmic environment. The stillness you feel is not wrong. It is only small. It is a local comfort inside a much larger motion. This is one reason the universe can feel so unsettling. Your senses tell you one story. Science tells you a deeper one. Your body says you are resting. The sky says the sun rises and sets. The ground says it is stable. But the larger picture says you are being carried through space at incredible speeds, without a sound, without a visible trail, and without any direct feeling of motion. You are moving, but the motion is too smooth and too shared to notice. That is the key. Shared motion hides itself. If Earth suddenly stopped rotating, the result would be catastrophic. But because Earth does not suddenly stop, and because it has been rotating steadily throughout your life, your body accepts the motion as normal. If Earth suddenly changed its orbital speed, we would notice the consequences. But because the orbit is stable and continuous, it feels like nothing. The universe is full of these hidden motions. Planets orbit stars. Moons orbit planets. Stars orbit within galaxies. Galaxies move in groups. Clusters move in larger patterns. Space itself expands on the largest scales. Motion is not an exception in the universe. It is the normal state. Stillness is what needs explaining. And when we look carefully, stillness usually turns out to be a local illusion, a temporary agreement between objects sharing the same movement. This changes the way we think about the room around us. A room is not a motionless box. It is part of Earth's rotating surface. Earth is not a motionless platform. It is a planet orbiting the sun. The sun is not a motionless lamp. It is a star traveling through the Milky Way. And the Milky Way is not a motionless island. It is a galaxy moving through a universe filled with other moving galaxies. Each familiar object is nested inside a larger motion. This is why the phrase "standing still" becomes almost impossible at cosmic scale. Standing still on Earth means keeping the same position relative to the ground. But the ground itself is moving. The planet is moving. The solar system is moving. The galaxy is moving. So, what does stillness really mean? It means choosing a frame, a reference point, a nearby thing to compare yourself against. If that reference point moves with you, you feel still. If it moves differently, you feel motion. That is why the stars seem to rise and set as Earth rotates. It is why the sun appears to cross the sky even though Earth is turning. It is why passengers on a train can feel still relative to one another while the train rushes across the land. Motion is relational, and the universe is made of relationships. Gravity creates many of those relationships. Earth moves because it formed with motion and because the sun's gravity bends its path. The moon moves because Earth's gravity holds it. The sun moves because it belongs to the Milky Way's gravitational system. Galaxies move because gravity pulls matter together into groups, clusters, and vast cosmic flows. Nothing is isolated from everything else. Every object carries the memory of how it formed and the influence of what surrounds it. This is why there is no simple cosmic stillness. To be truly still, an object would need to have no motion relative to some absolute background. But the universe does not work like a room with fixed walls. It is dynamic. It expands. It contains gravity. It contains matter in motion. It contains energy, fields, radiation, and structures changing over time. Even objects that appear frozen are part of motion. A mountain is still relative to Earth, but Earth rotates. A planet may seem steady in its orbit, but the orbit is motion. A star may appear fixed in the night sky, but it moves through the galaxy. A galaxy may look like a silent island, but it moves with other galaxies. The deeper we look, the more stillness disappears. This can feel terrifying, but it is also beautiful. It means you are never separate from the motion of the cosmos. Every quiet moment on Earth is part of a vast movement that began long before you existed. The atoms in your body are carried by Earth's rotation, by Earth's orbit, by the sun's journey through the galaxy, and by the motion of the Milky Way itself. You are not watching the universe from outside, you are inside its motion. That is why the first chapter of this journey has to begin with your own feeling of stillness. Before we talk about planets, stars, galaxies, and expansion, we have to understand why the most basic feeling is misleading. The universe does not reveal motion directly when motion is shared. It hides it inside normal life. The calm floor beneath you is part of a spinning planet. The quiet night around you is part of an orbiting world. The steady sun in the sky is a moving star. The familiar Milky Way is a moving galaxy, and every layer of stillness is sitting on top of a deeper layer of motion. Once you understand that, the next step becomes unavoidable. If your stillness is an illusion, then the first hidden motion to examine is the one happening directly beneath you. Earth's rotation. The spin of the planet. The motion so constant, so familiar, and so perfectly shared by everything around us that we almost never feel it at all. Earth's rotation is the first hidden motion beneath your feet. It is the reason the sun appears to rise in the east and set in the west. It is the reason the stars seem to move across the night sky. It is the reason one side of Earth turns towards sunlight while the other side turns into darkness. Every day of your life is built on this rotation, and yet the motion itself feels almost completely invisible. You do not wake up feeling the planet spin. You do not hear the ground rushing through space. You do not feel the room turning with Earth. You simply call it morning, afternoon, evening, and night. That is how deeply Earth's rotation is hidden inside normal life. We experience the result of the spin, but not the spin itself. We see shadows move. We see the sun cross the sky. We watch stars appear at night. We measure time in days. But the turning planet beneath all of this feels like a stable floor. This is one of the greatest tricks of perspective. Earth is rotating once every day. The planet is not a motionless platform under the sky. It is a huge spinning world, carrying oceans, continents, clouds, cities, forests, deserts, mountains, and every living thing around its axis. The ground beneath you is part of that rotation. The air above you is mostly moving with it. The buildings around you are moving with it. Your body is moving with it. Because everything nearby shares the motion disappears from feeling. If you were floating far above Earth and could watch the planet turning below you, the motion would be obvious. You would see clouds rotating around the globe. You would see continents move from sunlight into darkness. You would see the line between day and night sweep across oceans and land. Earth would look alive with motion, even if nothing on the surface seemed to notice. But from the surface, the same motion feels like stillness. This is because we live inside the rotating frame. Our senses are adapted to local changes, not the full planetary motion. When you stand on Earth, you are not standing outside the spin and watching it happen. You are being carried by it. Everything close enough to matter in everyday life is carried with you. That shared movement creates the feeling of rest. It is similar to sitting inside a train moving smoothly at constant speed. If the windows are covered and the ride is smooth, the inside can feel still. A bag rests on the floor. A drink stays in place. People can sit, talk, and walk. But from outside, the train is moving across the land. The stillness inside is real only relative to the train. Earth is like that, but on a far greater scale. We are passengers in a rotating world, and the windows are the sky. The reason we notice day and night is not because the sun is traveling around Earth. It is because Earth is turning. The sun appears to move because our viewpoint is rotating beneath it. The same thing happens with the stars. At night, the sky seems to rotate overhead, but most of that motion comes from Earth turning under the stars. For thousands of years, this was not obvious. It was natural to think the sky was moving around us. That is what the senses say. The ground feels stable, and the heavens appear to turn. But science slowly revealed the deeper truth. Earth is the moving object. The sky appears to move because we are on a spinning planet. This was one of the great perspective shifts in human history. It forced us to realize that feeling still does not mean being still. The ground can feel fixed while the planet rotates. The sky can appear to move while Earth is the thing turning. This is the same kind of lesson we will meet again and again as the scale grows. The universe often looks one way from our position and then becomes something very different when we understand the motion behind it. Earth's spin is the first example. It is also the easiest to take for granted, because it is perfectly ordinary to us. A day is so familiar that it does not feel like evidence of cosmic motion. We think of it as time passing, not as Earth rotating. But every sunrise is proof that the planet has turned. Every sunset is proof that your side of Earth is rotating away from the sun. Every star trail in a long exposure photograph is a record of Earth's motion. The spin is always there. It is just translated into sky. This translation can make motion feel peaceful. A spinning planet sounds violent, but a sunrise feels gentle. A rotating globe sounds unstable, but a day feels normal. The planet is turning fast, but because the motion is steady and shared, it becomes the rhythm of life. Life on Earth evolved inside that rhythm. Animals sleep and wake by it. Plants respond to it. Weather patterns are shaped partly by the planet's rotation. Ocean currents and atmospheric flows are influenced by the fact that Earth spins. Even though we do not feel the spin directly, the planet's rotation is woven into the conditions of life. It is not just an astronomical detail. It is part of the structure of Earth. If Earth did not rotate, the planet would be completely different. Day and night would not cycle in the same way. Temperatures would be more extreme. Winds and oceans would behave differently. The shape of the planet would be different too, because rotation slightly bulges Earth at the equator. The world we know is partly a world made by spin. So the first answer to why nothing is ever still begins here. Even our stable home is built on motion. The Earth is not a stage. It is a turning body, and you are standing on it. The strange part is that the faster motion does not always feel more dramatic. A person at Earth's equator is carried around the planet at a high speed, yet can stand calmly on a beach and feel nothing unusual. This is because speed alone is not what your body feels. Your body feels changes in speed and direction, forces, vibrations, and accelerations. Smooth shared motion can vanish from experience. That is why you do not feel Earth's rotation as wind blasting against you. The atmosphere is rotating with the planet. It is not left behind while Earth spins underneath it. The air is part of the moving system too. If the air were not moving with Earth, the surface would face unimaginable winds. But because the air and ground share the planet's motion, the world feels calm. This is another example of motion hiding inside relationship. The air feels still because it is moving with us. The ground feels still because we are moving with it. The room feels still because everything inside the room shares the same turning planet. Stillness is not the absence of motion. It is the absence of noticeable relative motion nearby. This idea may seem simple, but it changes the whole video. Once we understand it, we stop trusting stillness as an absolute feeling. We begin to ask what frame of reference we are using. Still compared to the chair? Still compared to Earth? Still compared to the sun? Still compared to the galaxy? Each answer is different. On Earth's surface, a sleeping person may be still compared with the bed, but that person is rotating with Earth. They are orbiting the sun. They are moving with the solar system through the Milky Way. The body feels at rest, but the cosmic path is enormous. Earth's spin is only the first hidden layer. It is the one closest to us, the one that creates the day, the one that shapes the sky every 24 hours. But it is also the one that teaches the most important rule. Motion can be real, even when it is not felt. The planet's rotation also gives us one of the clearest visual proofs of hidden motion: the stars. If you take a long exposure photograph of the night sky, the stars appear to form arcs around a point. Those arcs are not the stars rapidly circling Earth. They are the record of Earth turning under the sky. The camera stays with Earth, and Earth rotates, so the stars leave curved trails across the image. The photograph makes the hidden motion visible. It turns stillness into evidence. The same is true of a sundial. A shadow moves across the ground because Earth is rotating beneath the sun's light. The shadow seems to creep slowly, but it is really the sign of a whole planet turning. Ancient people used this motion to measure time long before they understood the full cosmic picture. They were reading Earth's rotation through the movement of light and shadow. In that sense, every clock is connected to motion. The day comes from Earth's spin. The year comes from Earth's orbit. Timekeeping is built from movement. This is another clue that stillness is not the foundation of the universe. Motion is. We measure our lives by repeating motions. The turning of Earth, the orbit around the sun, the phases of the moon, the cycles of the sky. The feeling of a still moment exists inside a world defined by motion. Even rest is timed by movement. That is a strange thought. When you say you spent 1 hour doing nothing, that hour still existed because Earth turned a little farther. The sun appeared to shift in the sky. The planet continued its orbit. The solar system continued through the galaxy. Your stillness was held inside many moving clocks. Nothing stopped for you to rest. The universe simply carried you quietly. This is why Earth's rotation is the perfect beginning. It is close enough to matter to everyday life, but hidden enough to challenge our senses. It shows that motion does not need to feel dramatic to be enormous. It shows that a person can be moving fast while feeling calm. It shows that the universe is not required to match human intuition. Our intuition evolved on the surface of Earth. But Earth itself is moving. That means our intuition begins inside motion, not outside it. The more we understand Earth's spin, the more we see that the ground is not the final reference point. It is only our local reference point, useful, familiar, and necessary for daily life, but not absolute. The ground is a moving surface on a rotating planet. The planet is one body in a moving solar system. The solar system is part of a moving galaxy. There is no final still floor hidden underneath. Only larger frames, each one carrying the smaller ones. This is also why Earth's rotation does not throw us away. A common question is why we do not fly off a spinning planet. The reason is that gravity holds us to Earth, and the rotation is not strong enough to overcome that gravity. Earth pulls you downward towards its center. Rotation slightly reduces your effective weight depending on where you are, especially near the equator, but it does not come close to throwing you into space. So Earth spins, and we remain attached. The planet turns, and oceans remain. Clouds move, winds form, weather circulates. The world is dynamic but stable enough for life. Motion does not always mean chaos. This matters because the video's main idea is not that everything is wildly unstable. The point is that motion is natural. Stable motion can exist. Orbits can last. Rotation can persist. Galaxies can move for billions of years. Stillness is rare not because everything is exploding, but because the universe is made of systems in motion. Earth's rotation is stable enough to feel like home. But it is still motion. That combination is important. The universe can be calm and moving at the same time. A planet can spin smoothly. A moon can orbit quietly. A star can travel through the galaxy without making a sound. A galaxy can drift through space while appearing frozen in a telescope. Motion is not always noise. Sometimes motion is silence. Earth's spin is silent to us because it has become the background of everything. It is too constant to notice, too shared to feel, too familiar to question. But once you remember it, the ordinary world becomes strange. A room is no longer a box at rest. A city is no longer fixed in space. A mountain is no longer an immovable object in the deepest sense. Everything on Earth is being carried through a daily circle. The still world is turning, and that turning is only the beginning, because Earth does not only rotate once per day, it also travels around the sun once per year. The spin gives us day and night, but the orbit gives us the year. The spin changes our view of the sun across hours. The orbit changes our position around the sun across seasons. These two motions are layered together. You are not simply spinning. You are spinning while orbiting. You are being carried around Earth's axis, while Earth is carried around the sun. This layered motion is the pattern that will repeat at every scale. The moon moves around Earth, while Earth moves around the sun. Earth moves around the sun, while the sun moves through the galaxy. The galaxy moves while the universe expands. Motion sits inside motion, and every layer feels still only when we forget the larger one. So after understanding Earth's rotation, the next question is not whether we are moving. We are. The next question is why we do not fly away in a straight line, and why Earth keeps returning around the sun year after year. The answer is gravity. Earth is not merely spinning in place. It is falling around the sun, and that motion will take us to the next layer of hidden movement, the one that turns a planet's path into an orbit and makes the entire solar system feel like a dance of falling worlds. That is what an orbit really is. Earth is not parked beside the sun like a still object held at a safe distance. It is moving, constantly and silently, along a curved path around our star. Every day, every season, and every year happens because our planet is not still. It is traveling. But from the surface, this motion is almost impossible to feel. You do not feel Earth racing around the sun. You do not hear the planet moving through space. You do not see the orbit beneath your feet. Instead, the year feels slow. The seasons change gradually. The stars visible at night shift little by little across the months. The motion is so large and so smooth that it becomes part of the background of life. But Earth is not resting. It is falling around the sun. That phrase sounds strange because we usually think of falling as moving downward. A stone falls to the ground. Rain falls from a cloud. A person falls from a height. But in space, falling has a deeper meaning. To fall means to move under gravity, and Earth is always moving under the gravity of the sun. The sun pulls on Earth constantly. If Earth had no sideways motion, it would fall inward toward the sun. But Earth does have sideways motion, inherited from the spinning disk of gas and dust that formed the solar system. So while the sun pulls Earth inward, Earth keeps moving forward. The result is not a crash. The result is an orbit. Earth keeps falling toward the sun, but it keeps missing. That is the simple heart of orbital motion. There is no solid track in space holding Earth in place. There is no invisible rail. There is no cosmic floor under the planet. Earth moves because it already has forward motion, and its path curves because the sun's gravity constantly bends that motion. Without gravity, Earth would continue in a straighter path. Without forward motion, Earth would fall inward. With both together, Earth circles the sun. An orbit is motion shaped by gravity, not stillness, not a planet resting in place, a moving relationship. This is one of the most important steps in understanding why nothing in the universe is ever truly still. Even the most stable-looking paths are still motion. Earth's orbit is reliable enough to build calendars. It is steady enough for life to evolve inside its rhythm. It is predictable enough for spacecraft to use. But reliability does not mean rest. A clock is reliable because it moves regularly. Earth's orbit is the same. The year is motion repeated. Every birthday, every winter, every summer, every anniversary, and every calendar page is built on Earth, completing another part of its path around the sun. We experience that motion as time, but the time is not separate from the movement. The year exists because Earth returns to a similar place in its orbit. The planet's path becomes part of human life, and yet we almost never feel it. The reason is the same as before. We are moving with Earth. Every mountain, ocean, forest, city, and person is traveling around the sun together. The atmosphere moves with the planet. The moon is carried along with us while orbiting Earth. The whole Earth-Moon system travels around the Sun as one moving structure. Because we share the journey, it feels still. If you could watch Earth from far outside the solar system, the motion would be obvious. You would see the planet circling the Sun year after year. You would see the Moon accompanying it, tracing its own path around Earth, while both move around the Sun. You would see a layered dance of gravity, not a still world under a fixed sky. But from the surface, the motion becomes normal. The Sun appears to change its path across the sky during the year. The constellations visible at night slowly change with the seasons. Some stars dominate winter nights, others summer nights. This is not because the stars themselves are moving around us in a yearly circle. It is because Earth is moving around the Sun, changing the direction we face into space at night. The night sky is a calendar of Earth's orbit, a hidden proof that the planet is moving. This is why the same constellations return at the same times each year. Earth is not watching the universe from one fixed seat. It is traveling around the Sun, and each part of the orbit gives us a different nighttime window into the galaxy. The sky changes because our position changes. The universe is not rotating around our calendar. Our calendar comes from our motion through the universe. That shift in perspective matters. The year is not just a human invention. It is an astronomical path. It is Earth's motion translated into seasons, star patterns, and timekeeping. Our lives are organized around a journey we cannot feel directly. Earth's orbit is like a hidden river. Everything on the planet is carried by it. We build houses, roads, cities, and civilizations on a surface that feels still. But the whole world is following a curved path through space. We sleep while Earth moves. We wake while Earth moves. We work, eat, speak, dream, and age while Earth continues falling around the Sun. The motion never pauses. There is no moment when Earth stops to rest before continuing. The orbit is continuous. This is why stillness becomes weaker as we look deeper. A planet does not need to stop in order to be stable. Stability can be a repeated motion. Earth's orbit is stable not because Earth is motionless, but because its motion remains regular over long periods. Life exists on a moving world because the motion is stable. That is the strange beauty of it. We often connect motion with danger. Something moving might crash, fall, shake, or break. But in space, motion is often what prevents disaster. Earth does not fall into the Sun because it is moving forward. The Moon does not fall straight into Earth because it is moving forward. Satellites remain in orbit because they are moving fast enough to keep missing the planet below them. Orbit is falling without landing. Motion becomes survival. If Earth somehow lost its forward motion around the Sun, the result would be catastrophic. The Sun's gravity would pull it inward. The orbit exists because Earth carries speed. So the motion that feels invisible is one of the reasons Earth remains where it is. We do not survive despite Earth's movement. We survive partly because that movement keeps Earth in orbit. Stillness would not save Earth. Stillness would destroy the orbit. This is a powerful idea. In the universe, rest is not always safe. A planet needs motion. A moon needs motion. A star in a galaxy needs motion. Systems remain structured not by objects sitting still, but by objects moving under gravity in long-lasting patterns. The solar system is not a frozen sculpture. It is a choreography. Every planet is moving around the Sun. Mercury moves quickly close to the heat. Venus follows its bright inner path. Earth carries us through 1 year at a time. Mars moves beyond us on a slower orbit. Jupiter travels far out, massive and powerful. Saturn, Uranus, and Neptune move through wider, slower paths in the outer darkness. None of them are still. They are all falling around the Sun. Each one moves at a speed connected to its distance. Closer planets travel faster. Farther planets move more slowly. Mercury races around the Sun in a short year. Neptune takes far longer than a human lifetime to complete one orbit. But every planet is part of the same basic story: forward motion, bent by solar gravity. The solar system is a family of falling worlds. This also means that when we look at planets in the night sky, we are not seeing fixed lights. We are seeing worlds in motion. Their positions change against the background stars because they are orbiting the Sun, and because Earth is orbiting too. The word planet comes from the idea of wandering, because planets seemed to wander across the sky compared with the fixed stars. But the wandering is not random. It is orbital motion seen from another moving world. That makes the night sky more complicated and more beautiful. We are not standing still while objects move around us. We are moving too. Every observation is made from a moving platform. Earth rotates, Earth orbits, the other planets orbit, the entire solar system moves through the galaxy. There is no outside stillness from which we watch the dance. We are in the dance. Earth's orbit also shows why enormous motion can be silent. The planet moves around the Sun at incredible speed, but you do not feel that speed because Earth's motion is smooth and shared. There is no air in space rushing against the planet like wind against a car. Earth is not pushing through a thick medium. It follows a gravitational path in near vacuum. Quietly, smoothly, constantly. This quietness is part of what makes space feel so eerie. Enormous motions happen without sound. Planets race through their orbits in silence. Moons circle worlds in silence. The Sun moves through the galaxy in silence. The universe is filled with motion, but most of it does not announce itself in ways our senses expect. The motion is real. The silence is real too. That combination creates the calm terror of astronomy. Everything is moving, but almost nothing sounds like it is moving. Because the Sun is not the final still point. It is only the local center. From Earth's point of view, the Sun feels like the heart of everything. From the solar system's point of view, that is true in a practical way. But from the galaxy's point of view, the Sun is one star among hundreds of billions, moving through the Milky Way with its planets around it. The Sun holds Earth. But the Sun itself is traveling. This is why the old classroom model can be useful but incomplete. A model with planets orbiting a stationary Sun helps us understand the solar system locally, but it can accidentally make the Sun feel like the final fixed object. It is not. It is only the center of the planet's local motion. The entire system is moving through a much larger frame. Earth spins, and we call it day. Earth orbits, and we call it year. The Sun moves, and it carries all of that motion into the galaxy. That is the pattern of the universe. Motion inside motion. A person may be still in a chair. That chair is on a rotating planet. That planet is orbiting the Sun. That Sun is moving through the Milky Way. Each layer feels still only because we live inside it. But each layer becomes motion when seen from a wider frame. Still compared to the chair. Moving compared to Earth's center. Moving compared to the Sun. Moving compared to the galaxy. All of these can be true at once. This is the key to the whole question. Stillness is not a universal state. It is a local description. It depends on what we compare ourselves to. Earth's orbit shows this clearly. From our daily point of view, the world feels steady. From a solar point of view, the planet is moving quickly around a star. From an even wider view, the whole orbit is being carried through the galaxy. Stillness keeps shrinking. Motion keeps expanding. And every new scale reveals another layer. A living world can be a traveler. Oceans can move around a star. Forests can grow on a falling planet. Cities can rise on a world that never stops moving. Every human story has taken place on a planet in orbit. The ground beneath history has always been moving. This is the emotional truth of Earth's orbit. Your life is not happening in a fixed place. It is happening on a moving planet, circling a star, carried through space with everything you know. Even sleep happens on a world in motion. Even silence moves. And because the sun itself moves, Earth does not return to the exact same place in the galaxy after every orbit. It returns around the sun, but the sun has moved onward. The path is layered. The motion is not a simple circle drawn in a motionless room. It is a planet orbiting a traveling star. The solar system is not a clock hanging on a wall. It is a clock carried through a galaxy. So after seeing Earth as a falling world around the sun, we have to zoom out again. The star that feels like the fixed heart of everything we know is not fixed at all. It is moving through the Milky Way, carrying Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and every small world with it. Earth's orbit gives us the year, but the sun's motion gives the entire solar system a larger journey. And that journey is the next hidden motion we have to follow, because the sun is not standing still. From Earth, the sun feels like the fixed center of everything. It rises, it sets, it warms the planet, and it holds the solar system together. Every planet we know moves around it. Every year on Earth is defined by our path around it. So it is natural to imagine the sun as the final anchor, the one thing in our local universe that does not move. But that picture is incomplete. The sun is only the center of the solar system. It is not the center of the universe. And it is not motionless. The sun is a star inside the Milky Way, and like other stars in our galaxy, it is moving. It travels through the galaxy with the planets around it, carrying Earth, Mars, Jupiter, Saturn, comets, asteroids, dwarf planets, dust, spacecraft, and every object bound to it. The whole solar system moves together through a much larger structure. This is one of the hardest motions to imagine, because we cannot feel it at all. Earth's rotation gives us day and night. Earth's orbit gives us the year. But the sun's journey through the galaxy is too large and too slow for human life to experience directly. We do not see the solar system crossing the Milky Way in the sky. We do not feel the direction of galactic travel. We do not notice the stars changing around us from one day to the next. But the motion is real. The sun is moving through the galaxy right now, and it is taking us with it. This changes the way we picture the solar system. The planets are not circling a star that is fixed in one place. They are orbiting a star that is moving through the Milky Way. Earth does not trace the same simple circle in a motionless room. Earth moves around the sun, while the sun moves onward through the galaxy. The result is motion inside motion, a planet orbiting a moving star, a moon orbiting a moving planet, a spacecraft leaving a moving world inside a moving solar system. Everything is layered. This is why classroom models are useful, but limited. A model with the sun in the center and planets moving around it helps us understand the local structure. It shows why Mercury is close, why Neptune is far, and why Earth takes 1 year to orbit. But if the model leaves the sun frozen in space, it hides the next scale. The solar system is not a clock sitting on a table. It is a clock being carried through a galaxy. The sun belongs to the Milky Way's disk, a huge structure of stars, gas, dust, and dark matter. The gravity of the galaxy shapes the sun's path, just as the sun's gravity shapes Earth's path. In the same way Earth does not fly away from the sun does not simply drift randomly through space. It moves as part of the galaxy's gravitational system. The Milky Way holds the sun, and the sun holds us. This is another example of nested motion. Gravity does not create one simple orbit and then stop. It creates layers of motion on many scales. The moon is bound to Earth. Earth is bound to the sun. The sun is bound to the Milky Way. The Milky Way is bound in a larger gravitational neighborhood with other galaxies. Each layer carries the one inside it, and each layer makes the idea of perfect stillness harder to defend. If you are sitting in a chair, you may be still relative to the chair. The chair is still relative to the room. The room is still relative to the ground. But the ground is rotating with Earth. Earth is orbiting the sun. The sun is moving through the Milky Way. Your stillness is real only inside the smallest frame. The wider frame is always moving. The sun's galactic motion also means that Earth does not return to the same place in the galaxy each year. Around the sun, Earth completes an orbit. But while Earth is doing that, the sun has moved onward. So the solar system does not reset to a perfect cosmic position after every year. The whole system has traveled along its larger path. A year brings Earth around the sun, but it does not bring the solar system back to where it was. This is a strange thought, because yearly cycles feel like returns. Seasons return, constellations return, birthdays return. The calendar repeats. From Earth, it feels as if time is moving in circles, but in the larger galaxy, every return is also part of a journey forward. The circle is being carried. The orbit becomes part of a path. This makes the solar system feel less like a flat diagram and more like a moving island. The sun is the island's center, and the planets are bound to it. But the whole island is traveling through the galactic sea. Around it are other stars, clouds of gas, dust, magnetic fields, and the faint material between stars. The solar system moves through this environment silently. We do not feel galactic wind in our faces. We do not see the stars rushing past like lights outside a train. The distances are too large. The motion is too smooth. The timescales are too long. Nearby stars do shift over time, but the change is slow from a human perspective. Across thousands of years, constellations begin to deform. Across millions of years, the night sky becomes very different. But during one lifetime, the sky feels almost fixed. The sun's motion is hidden not because it is small, but because space is enormous. Even fast motion can look slow when the distances are vast. This is one of the great tricks of cosmic scale. A star can move through the galaxy at a tremendous speed and still appear almost motionless in the sky for generations. A galaxy can move toward another galaxy and still take billions of years to collide. Motion in space often happens on scales where human intuition fails. The sun is moving, but the galaxy is so large that the journey feels frozen. In this way, the solar system is like a ship moving through a dark ocean, except the ocean is not water. It is the thin material between stars. The ship is made of gravity and solar wind. The planets are carried inside it, and Earth, with every living thing on it, is a tiny world inside that moving system. That image changes the meaning of home. Home is not a fixed location in the universe. Home is a moving system we belong to. Earth is home because we move with it. The solar system is home because Earth moves with the sun. The sun is our star because it carries the gravitational family that includes us. But none of this means stillness. Home is motion shared so completely that it feels like rest. The sun's journey makes this clearer than almost anything else. If the sun suddenly stopped moving through the Milky Way, that would not make the universe more stable. It would be an impossible change to the system's motion. Stars move because they are part of the galaxy's gravitational structure. Motion is not a mistake. It is how the system exists. The sun does not need to be still to be stable. It needs to move in the way the galaxy allows. This is similar to Earth's orbit. Earth remains stable because it moves around the sun. The sun remains part of the Milky Way because it moves through the galaxy under gravity. Stability is not the absence of motion. Stability is motion that can continue. This idea repeats at every scale. A spinning Earth can support life. An orbiting Earth can remain in the habitable zone. A moving sun can carry the solar system through the galaxy. A moving galaxy can remain part of a larger cosmic structure. Motion and order are not opposites. In space, they often create each other. This does not make the sun less important. To Earth, the sun is everything. It gives light, heat, and the gravitational center of our planetary system. Without the sun, Earth would not be the world we know. But importance is not the same as stillness. Something can be central locally and still move globally. The sun is our local center. But it is also a traveler. That makes our star feel more alive in the cosmic sense. Not alive biologically, but dynamic. It is not a lamp hanging in a dark room. It is a massive star moving through a rotating galaxy, carrying its planets with it, crossing interstellar space over millions and billions of years. The sun has a path. It has a past location and a future location. It has moved through different regions of the Milky Way and will continue to do so. The solar system has a galactic history. That history is mostly invisible to us because our lives are short. We cannot watch the sun complete its journey around the Milky Way. We cannot see the full galactic orbit unfold. We can only infer it, measure it, and imagine it. But the fact that we cannot feel the motion does not make it less real. The universe is full of things too slow, too large, or too smooth for direct sensation. Science reveals them anyway. This is why the next step beyond Earth's orbit feels so important. The sun is the thing that made Earth's orbit understandable. But now the sun itself becomes part of a larger orbit. The center becomes a passenger. The anchor becomes an object in motion. The frame we use to explain one layer becomes part of the next layer. That is the pattern of cosmic understanding. Every answer becomes a doorway. Earth's spin explains day and night, then leads to Earth's orbit. Earth's orbit explains the year, then leads to the sun's motion. The sun's motion explains the solar system's journey, then leads to the motion of the Milky Way. And beyond that, galaxies move too. Motion never ends at the next scale. It only becomes larger. For a viewer on Earth, this can feel almost dizzying. You begin in a quiet room. Then you remember Earth is spinning. Then you remember Earth is orbiting. Then you remember the sun is traveling through the galaxy. The feeling of stillness becomes smaller and smaller until it is only a local experience inside a vast moving universe. But that does not make the quiet room fake. It makes it part of a bigger truth. You really can rest. You really can sit still relative to your surroundings. But your surroundings are moving with you. This is the calm version of the terrifying idea. The universe does not need to feel chaotic for everything to be moving. Motion can be smooth enough to become peace. The sun's galactic journey does not shake Earth each morning. It does not tear the planets away. It does not create a visible trail behind the solar system. It simply carries us through the Milky Way in silence. A silent motion so large that our whole history happens inside a tiny part of it. Human civilization has risen during only a small moment of the sun's galactic path. The entire written history of humanity is almost nothing compared with the time it takes the sun to move around the galaxy. We have built cities, crossed oceans, invented machines, launched spacecraft, and mapped distant galaxies while our star continued its slow journey through the Milky Way. The sun carried all of it. Every empire, every language, every discovery, every quiet night. The solar system kept moving. This is why the sun's motion is not just a fact about astronomy. It is a reframe for existence. It means that the place we call home is not a point, but a path. Earth's location is not one fixed coordinate forever. It is a moving position inside a moving system. The solar system is not only where we are, it is how we travel. Home is a journey we do not feel, and that journey leads to the next question. If the sun is moving through the Milky Way, Then what about the Milky Way itself? Is the galaxy the final fixed background? Is there any reason to think our galaxy is still while stars move inside it? Or is the Milky Way also traveling through space, pulled by gravity, shaped by nearby galaxies, and moving as part of a larger cosmic flow? The pattern we have seen so far suggests the answer before we even ask. Earth is not still, the Sun is not still, and the Milky Way is not still either. For most of human history, our galaxy felt like the final background. When people looked up at the night sky, the Milky Way appeared as a pale river of light, stretching across the darkness. It looked distant, ancient, and fixed. Stars seemed to belong to it, like sparks frozen in a black ceiling. Even after we learned that the Milky Way is a galaxy filled with hundreds of billions of stars, it was still easy to imagine it as a vast, unmoving island, a great city of stars, a home too large to move. But the Milky Way is not frozen in space. It rotates, it drifts, it is pulled by gravity, it moves with other galaxies around it, and it carries the Sun, Earth, and every planet with it. This is the next scale of the same illusion. A person feels still because the room moves with Earth. Earth feels stable because it moves smoothly around the Sun. The Sun feels central because it holds the solar system together. And the Milky Way feels like the final background because it is so enormous that its motion is almost impossible to imagine. But size does not create stillness. A galaxy can be enormous and still move. The Milky Way is not a solid object like a wheel made of metal. It is a vast gravitational system made of stars, gas, dust, dark matter, and invisible forces. Its stars are not nailed into place. They move in long paths around the galactic center. Clouds of gas move. Star-forming regions move. The spiral arms are not hard structures, but patterns inside a rotating galaxy. The whole system is dynamic. From inside it, that motion is hard to see. We live deep within the Milky Way, not outside it. We cannot step away and watch the whole galaxy turn like a glowing disk. Our view is trapped inside the disk itself, surrounded by stars in every direction. Dust blocks parts of the galaxy from visible light. Distance compresses depth. The Milky Way becomes a band across the sky instead of the full structure we know it must be. Once again, we are inside the moving thing. And being inside makes motion feel like stillness. The Sun is moving around the galaxy, but so are many nearby stars. We share part of the Milky Way's motion with our neighborhood. That shared movement makes the galaxy feel calm. The stars do not streak past us like rain on a window. They shift slowly, over timescales far longer than a human life. The galactic motion is real, but hidden by scale. This is why the Milky Way can look eternal. It changes too slowly for our eyes. If we could speed up time, the galaxy would no longer seem frozen. Stars would stream around the center. Gas clouds would drift, collide, and collapse. New stars would ignite. Old stars would die. Spiral patterns would shift. Nearby stars would change positions in the sky. The familiar constellations would dissolve into new shapes. The Milky Way would become alive with motion. But because we live for such a short time, we see only a still frame. A single moment in a galactic movie. That is one of the deepest reasons the universe feels still. We do not live long enough to watch most of its movements unfold. Earth's rotation is fast enough to feel as day and night. Earth's orbit is fast enough to become a year. But the Sun's path through the Milky Way takes far longer than civilization. The galaxy's larger motion takes even longer to understand. Our senses are not built for galactic time, so the galaxy appears still. But stillness is not the truth. The Milky Way rotates because gravity holds its matter in motion. Stars orbit the galactic center in enormous paths, each one shaped by the mass of the galaxy. The Sun is one of those stars. It is not hanging motionless inside the disk. It is part of the galactic flow, moving around the center with the rest of the stellar system. This means that when we say the Sun carries the solar system through the Milky Way, we are only describing one part of the larger picture. The Sun is traveling because it belongs to the galaxy. The galaxy's gravity shapes its path. The same kind of idea repeats again. A smaller system moves inside a larger one. Earth moves because it belongs to the Sun. The Sun moves because it belongs to the Milky Way. And the Milky Way moves because it belongs to a larger gravitational neighborhood. There is no final stop. The Milky Way itself is part of a group of galaxies. It is not alone in an empty universe. Nearby galaxies, including Andromeda and many smaller galaxies, share a gravitational environment. These galaxies are not fixed dots separated by dead space. They influence one another. They move relative to one another. They fall, drift, and slowly change positions over cosmic time. The Milky Way and Andromeda are especially important in this story because they are moving toward each other, not in a way that matters to any human lifetime, but in a way that matters to the future of the galaxy. Over billions of years, gravity is drawing them together. The night sky we know is temporary. One day, the Milky Way's future will be shaped by a meeting with another giant galaxy. That does not mean stars will crash like cars on a road. Galaxies are mostly empty space. But gravitationally, the encounter will be enormous. Stars will be rearranged. Gas may be stirred. The shapes of the galaxies will change. What feels like a permanent galactic home is actually part of a long future transformation. Even galaxies have destinies. And destiny in the universe usually means motion. From Earth, however, the Milky Way remains quiet. It does not look like a river. It looks like a soft white band. The motion is hidden behind distance, darkness, and time. This is another example of the video's central idea. The universe does not need to look like it is moving in order to be moving. The most enormous motions can appear peaceful. The most powerful gravitational paths can look like stillness. A galaxy can travel through space while seeming frozen above a field at night. This is why scale is so deceptive. When something is small and fast nearby, we notice it. A bird flying across the sky is obvious. A car passing on a road is obvious. A wave moving across water is obvious. But when something is huge, distant, and moving over millions of years, our senses fail. The motion is too large to fit inside experience. The Milky Way is moving beyond human scale. That does not make the motion less real. It makes it more humbling. This is hard to picture because the Milky Way is not something we stand on like a planet. We live inside one small planetary system within it. The galaxy is both our home and our sky. It surrounds us, but we cannot see it all at once. We are like people inside a vast moving ship, trying to understand the ship by looking out through small windows. The windows show stars. The full motion has to be reconstructed. And it is the reason this question is so powerful. Why is nothing in the universe ever still? Sounds simple, but it forces us to examine what we mean by still. If the Earth moves, we might look to the Sun. If the Sun moves, we might look to the Milky Way. If the Milky Way moves, we must look beyond the galaxy. Each time, the possible resting place disappears. The Milky Way's motion is the point where the idea of a fixed home begins to completely collapse. A planet can feel like home. A star can feel like home. A galaxy can feel like home. But none of them are still. Home is not a stationary place. Home is a moving set of relationships. Earth stays with the Sun because of gravity. The Sun stays in the Milky Way because of gravity. The Milky Way moves with nearby galaxies because of gravity. The same force that gives structure also prevents perfect stillness. Gravity connects objects, bends paths, and turns isolated motion into shared motion. Without gravity, the universe would not have the same kind of structure. With gravity, matter gathers, orbits, falls, merges, and moves. Stillness becomes rare because connection creates motion. This is why the Milky Way's motion is not random. It is shaped by the mass around it. Nearby galaxies pull on one another. Larger structures influence the group. The galaxy is not wandering aimlessly like a lonely object in a blank void. It is part of a web of gravitational relationships. The universe is not just things in space. It is things affecting one another. That is why no object can easily be separated from motion. This makes the feeling of sitting still even stranger. A person, lying in bed at night, may feel completely motionless. But their real cosmic motion is layered through the planet, the star, the galaxy, and beyond. The body rests, the planet spins, the planet orbits, the star travels, the galaxy moves. Rest exists locally, motion exists cosmically. Both are true, depending on the frame. The Milky Way's motion shows why frames matter. From inside the galaxy, we can describe stars moving relative to us. From a broader view, the whole galaxy is moving relative to other galaxies. From an even broader view, galaxy groups move relative to one another. There is no single view that turns everything into perfect stillness. There are only useful perspectives. This does not mean science becomes meaningless. It means science must be careful. Motion is measured relative to something. Another object, a center of mass, a galaxy, a cosmic background, or a chosen coordinate system. The more carefully we define the frame, the more clearly we understand the motion. The universe does not give us stillness. Automatically, we define reference points to make sense of movement. That is why everyday life and cosmic reality can both be correct. A house can be still compared with the ground. Earth can move compared with the sun. The sun can move compared with the galaxy. The galaxy can move compared with other galaxies. There is no contradiction. There is only scale. The Milky Way is the scale where the question becomes deeply cosmic. Because now we are no longer talking only about planets and stars. We are talking about galaxies themselves. And once galaxies are moving, the universe feels very different. A galaxy is not a final island of stability. It is an object in a larger ocean of gravity. It can approach other galaxies. It can merge. It can be pulled by unseen mass. It can become part of clusters and filaments. It can move through a universe that is structured on scales far larger than the galaxy itself. The Milky Way is huge to us. But to the universe, it is one moving part. The Milky Way's motion does not make it less important. It makes it part of a grander system. Our galaxy is not a lonely frozen island. It belongs to a gravitational neighborhood. It has relationships. It has a future. It is pulled, shaped, and carried by the universe around it. This is why the night sky should feel different once you know the galaxy moves. The band of the Milky Way is not just a pretty background. It is the inside view of a moving galaxy. Every bright star is part of that system. Every dark dust lane is part of that system. Every nebula, cluster, and stellar stream belongs to a galaxy that is rotating, evolving, and traveling through a larger cosmic environment. The sky is not a ceiling. It is the interior of a moving structure, and Earth is inside it. That is where the next transition begins. If the Milky Way moves, then it is natural to ask what drives that larger motion. A planet moves because of a star. A star moves because of a galaxy. A galaxy moves because of other galaxies and larger structures. The pattern keeps growing outward. The next layer is not about one galaxy alone. It is about galaxies falling through space. Because the Milky Way is only one member of a larger gravitational story. Around it, beyond it, and far outside our local sky, galaxies are not scattered randomly like fixed lights. They gather into groups, clusters, filaments, and enormous flows. They pull on one another across distances that almost break the imagination. So the question becomes even bigger. If galaxies themselves are moving, what does motion look like on the largest structures in the universe? And how far can this chain of movement go before stillness disappears completely? To answer that, we have to leave the scale of stars and enter the scale of galaxies. Because galaxies do not simply sit in space like distant islands. They move, they fall, they gather. They pull on one another across distances so large that the mind almost refuses to hold them. From Earth, galaxies look peaceful. In telescope images, they appear frozen in the dark. Spirals, glowing disks, stretched arms, bright cores, and soft clouds of ancient light. A galaxy can look like a perfect silent shape, suspended forever in black space. Nothing about the image seems urgent. Nothing seems to be rushing. Nothing seems to be falling. But a telescope image is only a moment, a still frame of a system that is moving through time. Galaxies are not decorations on the wall of the universe. They are enormous structures made of stars, gas, dust, dark matter, and gravity, and they exist inside a larger cosmic environment. They feel isolated only because the distances between them are so vast. But distance does not remove gravity. It only makes gravity work slowly. Over billions of years, galaxies respond to one another. They drift toward groups. They fall into clusters. They pull smaller galaxies apart. They merge. They reshape one another. They move through space in ways that are almost invisible to a human lifetime, but obvious to the universe. This is the next answer to why nothing is ever still. Once matter exists, gravity begins to connect it. And once gravity connects it, motion follows. A galaxy is not free from the universe around it. It feels the pull of other galaxies, the influence of dark matter, and the structure of the cosmic web. So even a galaxy, something so large it contains hundreds of billions of stars, is still part of a larger fall. The word falling is important here again. A galaxy falling through space does not mean it is dropping downward, because there is no universal down. It means the galaxy is moving under gravity. Just as Earth falls around the Sun, galaxies fall through larger gravitational landscapes. They are drawn toward mass. They move toward one another. They follow paths shaped by gravity on scales far beyond the solar system. Falling is not always a crash. Sometimes falling is an orbit. Sometimes it is a merger. Sometimes it is a long, slow drift toward a larger structure. The universe is filled with falling on many scales. The Milky Way is part of this too. It belongs to a small family of galaxies called the Local Group. This group includes our galaxy, Andromeda, and many smaller galaxies. These galaxies are not fixed in place. They are gravitationally connected. They move around one another, influence one another, and slowly change their relationships over time. The Milky Way is not alone. It is moving inside a group, and that group is also part of a larger environment. This is where stillness becomes even harder to imagine. If Earth is moving around the Sun, and the Sun is moving through the Milky Way, and the Milky Way is moving with other galaxies, then there is no simple local object we can point to and say, there, that is the thing that finally rests. Every anchor becomes a passenger. Every background becomes part of a larger motion. Every still frame becomes a moving scene when the scale increases. The local group itself is not a rigid object. It is not a solid structure with borders like a country on a map. It is a gravitational relationship between galaxies. Some are large. Many are small. Some orbit larger galaxies. Some are being stretched, disturbed, or absorbed. Over cosmic time, the group changes. Galaxies can consume smaller galaxies. They can tear streams of stars from one another. They can pass close enough for gravity to twist their shapes. They can merge into larger systems. The universe builds structure by motion, not by placing things neatly and leaving them there. This is why galaxy collisions are so important. The word collision sounds violent, and on the scale of galaxies it is. But it is not like two solid objects smashing together. Galaxies are mostly empty space, so individual stars usually do not hit one another. Instead, the real violence is gravitational. The shapes of galaxies distort. Gas clouds can be compressed, new star formation may be triggered. Orbits change. The galaxies slowly become something new. A galaxy merger is motion becoming transformation. The Milky Way itself has a history of this. Like many large galaxies, it grew by gathering smaller systems over time. It carries traces of past interactions, streams, and old stellar populations that tell a story of motion and absorption. Our galaxy is not pure and untouched. It has been shaped by gravity, by smaller galaxies, and by time. That means we live inside a structure built by previous motion. The galaxy under our night sky is not only moving now, it was made by motion. This is the deeper pattern. Motion does not just move objects from place to place. Motion creates history. It turns gas into stars. It turns stars into galaxies. It turns galaxies into groups. It turns groups into clusters. It turns the universe into a web. The cosmic web is the large-scale structure of the universe. Galaxies are not scattered evenly like dust in a room. They gather along filaments, around clusters, and near massive regions, leaving enormous emptier voids between them. From a great enough distance, the universe looks almost like a network, bright threads of galaxies surrounding dark, empty regions. This web is not still either. Galaxies flow along it. Clusters pull matter inward. Voids expand in relative emptiness. Filaments guide motion. The largest structures are not solid objects, but patterns of matter and gravity changing with time. This is where the idea of galaxies falling through space becomes truly cosmic. A single galaxy may move toward another galaxy. A group may move toward a cluster. A cluster may be influenced by even larger concentrations of mass. Gravity creates flows, and galaxies become markers of those flows. They show us where matter has gathered and where it is still moving. The universe is not a calm container filled with stationary islands. It is a moving network. Even the empty regions help create motion. A void is not pulling galaxies inward the way a cluster does, but as matter gathers elsewhere, the low-density regions become part of the pattern. Galaxies are drawn toward denser areas, leaving emptier spaces behind. Over time, the contrast grows. The cosmic web becomes more defined. Structure forms because matter moves. Again and again, stillness loses. At human scale, a galaxy image can feel eternal. A spiral galaxy in a photograph looks like a sculpture made of light. But if we could watch it over hundreds of millions of years, the arms would change. Stars would orbit. Gas would move. Nearby companions might tug at it. The galaxy would rotate, evolve, and respond to its surroundings. The beauty of a galaxy is not the beauty of stillness. It is the beauty of motion, too slow for us to watch. This is one of the most important emotional ideas in the video. The universe often looks calm not because it is not moving, but because we are too brief to see the movement. A mountain looks still because its changes are slow compared with a person. A star looks fixed because its motion is tiny across a lifetime. A galaxy looks frozen because its evolution takes cosmic time. Stillness is often just impatience from the universe's point of view. We are too short-lived to see the motion, but the motion is there. Galaxies also reveal that speed is not always the same as visible movement. A galaxy can be moving at enormous speed relative to another galaxy, yet because it is so far away, its position in the sky barely changes. The same thing happens with stars, but galaxies make it even more extreme. Distance turns motion into silence. Time turns change into stillness. This is why astronomy depends on measurement, not only appearance. We use light to understand motion. A galaxy's light can be shifted depending on how it moves relative to us, and how space itself is expanding. Its shape can reveal past interactions. Its companions can reveal gravitational relationships. Its gas can show disturbances. The universe leaves evidence of motion even when our eyes cannot watch the motion directly. Motion hides, but it also leaves clues. The more we follow those clues, the less the universe looks like a still place. This is why two galaxies can begin millions of light years apart and still be part of one future story. Gravity does not need human speed. It has cosmic time. Over billions of years, small pulls become huge changes. Galaxies that once seemed separate can approach, interact, and merge. Groups can evolve. Clusters can grow. The universe rearranges itself through slow persistence. Nothing needs to hurry when there are billions of years. This is a difficult idea for the human mind because our lives are built around short timescales. We understand motion when we can see it. A falling object, a passing car, a wave, a bird, a storm. But cosmic motion often works beyond direct experience. It can be enormous, silent, and slow, yet still determine the future of entire galaxies. A galaxy falling through space is not less real because it takes billions of years. It is only less human. The Milky Way's own future with Andromeda is a perfect example of this kind of motion. From our point of view, Andromeda looks like a faint object in the night sky, distant and quiet. But it is part of our gravitational future. The two great galaxies are moving toward a long interaction that will unfold far beyond the span of human history. To us, Andromeda is a smudge of light. To gravity, it is a destination. That is the strange difference between appearance and reality. The sky shows stillness. Gravity writes motion. As galaxies move, they also carry everything inside them. If the Milky Way moves, the Sun moves with it. If the Sun moves, Earth moves with it. If Earth moves, we move with it. So when galaxies fall through space, the motion is not distant from us. It is not just something happening out there. It is part of the chain that includes our own bodies. You are not only on a planet orbiting a star. You are inside a galaxy, moving with other galaxies. Your stillness is tied to galactic motion. That is the scale of the illusion. A person can lie completely still in a quiet room while being carried by a galaxy that is itself moving through a larger gravitational web. The body can rest. The room can be quiet. The night can feel peaceful. But the larger system never stops. This does not make human rest meaningless. It makes it more astonishing. Rest is something we experience locally, inside a universe that never truly rests globally. But this leads to an even bigger question. If galaxies are moving toward one another under gravity, and if groups and clusters are part of larger flows, then what happens when we include the expansion of the universe? Because on the larger scales, galaxies are not only moving through space, the space between distant galaxies is also growing. This is where the story changes again. So far, we have talked about motion inside structures, Earth around the Sun through the Milky Way with other galaxies. But the universe adds another layer that is stranger than ordinary motion. It is not just that objects move through space. On the largest scales, space itself expands. That expansion does not erase gravity inside galaxies and groups. The Milky Way is not expanding like a balloon. Earth is not drifting away from the Sun because of cosmic expansion. Local gravity holds systems together, but far beyond bound structures, across enormous distances, the expansion of space becomes one of the dominant motions of the universe. This is why the next step is so strange. Galaxies can fall toward one another locally, but very distant galaxies can also recede as space itself expands between them. Motion is no longer only objects moving through a cosmic arena. The arena is changing too. And once we reach that scale, the idea of a still universe becomes almost impossible to keep. Because if even space itself is stretching, then stillness is not simply rare. It may have no final place to exist at all. So far, the motion has been easier to picture. Earth spins. Earth orbits the sun. The sun moves through the Milky Way. The Milky Way moves with other galaxies. These are all motions of objects through space, even if the scales become enormous. A planet travels around a star. A star travels through a galaxy. A galaxy moves through a larger gravitational environment. But the expansion of the universe is different. It is not just another object moving across a background. It is the background changing. On the largest scales, the distances between distant galaxies grow over time. Space itself expands, carrying galaxies farther apart, where gravity has not bound them together. This does not mean every object in the universe is stretching. Earth is not expanding. Your body is not expanding. The solar system is not being pulled apart by cosmic expansion. The Milky Way is not growing because space inside it is stretching in the same way. Gravity, electromagnetism, and local structure hold things together. But far beyond galaxies, far beyond groups, far beyond bound systems, the expansion of space becomes one of the main facts of the universe. And this makes motion stranger than anything we have seen before. When a distant galaxy appears to move away from us because of cosmic expansion, it is not always moving through space in the same way a rocket moves through space. Instead, the space between us and that galaxy is increasing. The distance grows because the fabric of the universe itself changes with time. This is difficult to imagine because we live inside space. We are used to thinking of space as the empty stage where things happen. Objects move through it. Light crosses it. Planets orbit inside it. Galaxies drift within it. Space feels like the container, not the thing that changes. But the universe does not behave like a frozen container. Space can expand. The stage itself can grow. This is one reason the universe has no simple stillness. If objects were only moving inside a fixed arena, we might imagine that somewhere there is a final frame, a perfect cosmic room, a place where the background is truly at rest. But if the arena itself changes, then stillness becomes even harder to define. The universe is not a room, it is a dynamic structure. The expansion is often imagined like an explosion, but that image can be misleading. In an explosion, material flies outward from a central point into empty space around it. There is a center of the blast. There is outside space for the material to expand into. But cosmic expansion is not like a bomb going off in a pre-existing room. The universe is not expanding from one central place into empty darkness. On the largest scales, space expands everywhere. Distant galaxies move away from one another because the distances between them grow. From any galaxy, far enough away, other galaxies would appear to recede. There is no special center where everything began moving away from one location in space. The expansion belongs to space itself. This is one of the hardest ideas in astronomy. There is no edge nearby that we are racing away from. There is no center we can point to in the sky. There is no outside wall of the universe that we can watch stretch. There is only a growing distance between faraway regions, a quiet, enormous expansion. And because of that, the question of stillness becomes strange again. If every distant galaxy sees other distant galaxies receding on large scales, then who is truly at rest? Which galaxy is the fixed one? Which point can claim to be the center? None of them. The expansion does not choose a throne. It gives no object the final privilege of stillness. This does not mean everything is moving away from everything else in every situation. Local gravity matters. The Milky Way and Andromeda are moving toward each other because they are gravitationally bound. Stars inside galaxies remain together. Planets remain with stars. Moons remain with planets. At small and local scales, gravity can overcome expansion. The universe is layered. Locally, gravity can pull. Globally, space can expand. That is why some galaxies fall together while very distant galaxies recede. Both can be true. This is important because otherwise the universe sounds contradictory. How can galaxies move toward each other if the universe is expanding? The answer is scale. In bound systems, gravity dominates. Across vast, unbound distances, expansion dominates. The universe is not doing one simple thing everywhere. It is a mixture of local attraction and large-scale expansion. Again, motion is relational. It depends on scale. The expansion of the universe also changes how we think about distance. A galaxy very far away is not just far in the way a mountain is far, or another planet is far. Its light has traveled across expanding space. While the light was traveling, the universe changed. The distance between galaxies increased. The light stretched with space, shifting toward longer wavelengths. So even light carries evidence that space has expanded. The universe writes its motion into the light we receive. The expansion means that the universe has a history. It was denser in the past. Galaxies were closer together. Light has traveled through a changing cosmos. The universe today is not the same as the universe billions of years ago, and it will not be the same billions of years from now. Stillness cannot survive in a universe with a past and future like this. The whole structure evolves, not just the objects inside it. The scale of this is almost impossible to feel from Earth. You can stand under the night sky and nothing seems to stretch. The stars look fixed. The moon follows its path. The planets move slowly. The Milky Way shines quietly if the sky is dark enough. There is no visible sign that the largest distances in the universe are growing. Expansion is too large to feel locally, too slow to notice directly in daily life, too vast to fit into human senses. But it is there, and once we understand it, the meaning of motion changes again. Before expansion, we could imagine motion as objects changing position in space. But with expansion, distance itself becomes active. Space is not just the empty gap between things. It has behavior. It can grow. It can carry light across changing distances. It can shape what faraway galaxies look like to us. This makes the universe feel less like a collection of objects and more like one evolving whole. A planet is moving, a star is moving, a galaxy is moving, and the space between distant galaxies is changing too. There is no layer where everything finally becomes static. The expansion also makes the idea of a universal center feel unnecessary. If space expands everywhere, then every observer in a distant galaxy can see themselves as sitting inside an expanding universe. From their point of view, faraway galaxies would also appear to recede. That does not mean they are the center. It means expansion has no ordinary center inside the universe. The center is not somewhere else. The concept does not work the way our intuition wants it to. This is uncomfortable because human thinking loves centers. A room has a center. A city has a center. A planet has a center. The solar system has a local center in the sun. A galaxy has a central region. But the expanding universe does not give us that same kind of simple center for everything. At the largest scale, the universe is not built around our kind of map. It is stranger than that. This is another reason the question of stillness becomes so powerful. Stillness often feels connected to a center, a fixed point, a place of rest, a foundation. But the expanding universe removes the foundation. There is no cosmic floor beneath all motion, no central platform from which the entire universe can be judged as moving or still. There are only frames, measurements, relationships, light, gravity, expansion, and the movement of everything inside them. A quiet room, a spinning planet, an orbiting world. a moving star, a drifting galaxy, an expanding universe, all at once. That layered truth is the heart of the video. Stillness is not destroyed because you move in one way. It disappears because every scale reveals another motion. The room is still relative to you. Earth turns under the sky. Earth falls around the sun. The sun travels through the galaxy. The galaxy moves with other galaxies. And across the deepest distances, space itself expands. There is no final resting layer, only larger descriptions. This is why the expanding universe should not be imagined as simple chaos. It is not everything flying randomly with no meaning. It is a universe with local structures, gravitational relationships, and large-scale expansion. Some things are bound. Some distances grow. Some galaxies approach. Some recede. The full picture is not simple, but it is not meaningless. It is a universe in motion at every level. And that brings us closer to the central question. If everything is moving, can anything be truly still? Maybe a particle? Maybe a galaxy? Maybe the universe as a whole? Or is stillness only something we define relative to something else? The expansion makes that question unavoidable. If space itself changes, then searching for one perfect place of rest may be the wrong approach. The universe may not contain an absolute still point in the way our everyday mind imagines. Instead, it may contain many useful frames of reference, each one describing motion from a different point of view. A person is still relative to a chair. Earth moves relative to the sun moves relative to the Milky Way moves relative to nearby galaxies. Distant galaxies recede as space expands. Every answer depends on the comparison. Stillness may not be a thing the universe gives us. It may be a relationship we create. That idea is strange, but it also solves the feeling of contradiction. You can be still and moving at the same time, because those words only make sense relative to a frame. Your body can rest in bed while Earth turns. Earth can orbit the sun while the solar system moves through the galaxy. A galaxy can move locally while distant space expands. The universe does not need one final answer for all frames. It works through layers. This is why the expansion of the universe is the most extreme layer so far. It is not just another motion added to the list. It changes the meaning of the list. It shows that even the stage on which motion happens is not fixed in the way we imagine. Space has a history. Distance has a history. Light crossing the cosmos has a history. The universe is not still because it is not finished. It is evolving. And we are inside that evolution. From Earth, we experience only a tiny, calm slice of it. Our lives unfold in rooms, cities, landscapes, and familiar skies. We feel still because our local world moves with us. But the deeper truth is always there. We are carried by structures much larger than ourselves, and those structures are carried by even larger motions, until the whole universe becomes a story of movement, expansion, and change. So the next question becomes sharper. If motion depends on comparison, and if every scale we examine is moving relative to something else, then is there any true still place at all? Is there a final frame of reference hidden somewhere in the universe? Or is stillness only a local illusion, useful for daily life, but impossible as an absolute cosmic state? To answer that, we have to stop chasing bigger and bigger objects for a moment and ask what motion really means. Not just planets moving, not just galaxies moving, not just space expanding, but the deeper question underneath all of it. Still, compared to what? That is the question that changes everything. Because when we ask whether anything in the universe is truly still, we first have to ask what stillness would even mean. A person can be still compared with a chair. A chair can be still compared with a room. A room can be still compared with the ground. But the ground turns with Earth. Earth orbits the sun The sun moves through the Milky Way, and the Milky Way moves among galaxies. So the word still does not stand alone. It always points to a comparison. This is the hidden problem. In everyday life, we rarely notice the comparison because the reference point is obvious. If a glass is sitting on a table, we say the glass is still. We do not mean it is motionless compared with the sun, or the galaxy, or the expanding universe. We only mean it is not moving relative to the table. That kind of stillness is real. But it is local. It works because the table, the room, and the glass share the same motion of Earth. They move together, so their motion relative to one another is small. The stillness is not absolute. It is a relationship between nearby things. This is why the feeling of rest is so convincing. Human life happens in small frames. Your body cares about the floor, the wall, the air, the bed, the car, the ground. If those things are moving with you, you feel calm. If they move differently, you notice. A sudden stop in a car, turbulence in a plane, a boat rocking on water, an earthquake beneath your feet. These are changes in motion that your body can feel. But smooth, shared motion can hide completely. A person asleep on Earth is not aware of rotation, orbit, galactic travel, or cosmic expansion. Their body is resting relative to the bed. Their breathing is slow. The room is quiet. Nothing in their local world says that they are moving through a chain of cosmic motions. The local frame says rest. The larger frame says motion. Both descriptions can be true. This is where the idea of absolute stillness becomes difficult. Absolute stillness would mean being at rest in some final, universal sense. Not just still compared with a chair. Not just still compared with Earth. Not just still compared with the sun. Truly still, compared with the universe itself. But what would that reference point be? Where is the universe's floor? Where is the final background? Where is the place that does not move? For a long time, humans naturally imagined such a background. The ground felt fixed, so Earth seemed fixed. Then the sun became the center of the solar system. Then the stars seemed like the distant fixed background. But each time we learned more, the fixed thing began to move. Earth rotated. Earth orbited. The sun traveled. Stars moved. Galaxies moved. Space expanded. The more carefully we looked, the less the universe looked like a still room. This does not mean motion is meaningless. It means motion must be described carefully. To say something moves, we have to say what it moves relative to. A spacecraft can move relative to Earth. Earth can move relative to the sun. The sun can move relative to nearby stars. A galaxy can move relative to another galaxy. Distant galaxies can recede because the space between them expands. There is no single simple sentence that captures all motion at once. There are frames, and every frame reveals a different truth. In physics, a frame of reference is the viewpoint or coordinate system used to describe motion. You can choose a frame attached to Earth, and the ground becomes still. You can choose a frame attached to the sun, and Earth moves around it. You can choose a galactic frame, and the sun becomes a traveling star. You can choose an even larger cosmic frame, and galaxies become part of enormous motions and expansion. The object does not change. The description changes because the frame changes. This is not just a technical detail. It is the reason stillness is so slippery. The same person can be resting, rotating, orbiting, traveling, and receding all at once, depending on the frame being used. There is no contradiction. There is only scale and comparison. A sleeping person is still in bed, moving with Earth, moving with the sun, moving with the Milky Way, moving inside an expanding universe. All of those are true. The mistake is thinking one must cancel the others. Everyday language usually chooses the smallest useful frame. If someone asks whether you are moving, You do not answer with the motion of the galaxy. You answer based on the room. That is useful. It helps life function. But astronomy forces us to widen the frame, and when we do, stillness begins to dissolve. The wider the frame, the more motion appears. This is why the question is not simply how fast are we moving. The deeper question is relative to what. Without that, speed has no complete meaning. A passenger walking inside a train may move slowly relative to the train, but quickly relative to the ground outside. A person on Earth may be still relative to the ground, but moving quickly relative to the sun. The motion depends on what is chosen as the background. In the universe, there is no obvious final background made of walls and floor. Space is not a room with painted coordinates. It is a dynamic setting filled with matter, gravity, light, and expansion. This can feel unsettling because the human mind wants an ultimate answer. We want to know our real speed, our real direction, our real motion. But the universe may not offer those words in the simple, everyday way we expect. It offers relationships instead. Motion is measured between things, and different relationships matter for different questions. For navigating on Earth, Earth's surface is enough. For sending spacecraft, the sun and planets matter. For studying stars, the galaxy matters. For studying the universe, cosmic expansion matters. Each scale has its own useful frame. None of them is the throne of absolute rest. This distinction matters because it keeps the science honest and the mystery intact. We can measure motion very well. We can describe how Earth moves around the sun, how the sun moves through the galaxy, how galaxies move relative to one another, and how space expands. But none of that requires a perfect universal still point. It only requires careful comparisons. Stillness is not the foundation. Measurement is. The more we accept this, the more the universe begins to feel less like a stage and more like a network of relationships. Earth is related to the sun through gravity. The moon is related to Earth. The sun is related to the Milky Way. The Milky Way is related to the local group. Distant galaxies are related through expansion and gravity across enormous scales. Motion is how those relationships reveal themselves. If nothing moved, there would be no orbit, no day, no year, no galaxy rotation, no falling together of galaxies, no expansion history, no cosmic story. A perfectly still universe would be almost unrecognizable. This means the search for a truly still place may be the wrong search. We may be asking the universe for something it does not contain in the way we imagine. We imagine stillness as a final condition, a place where all motion ends. But in the real cosmos, stillness may only exist locally, temporarily, and relationally. Still compared with this. Still for now. Still inside a chosen frame. Not still forever. Not still absolutely. Not still from every possible view. This changes how we understand ourselves. You are not wrong to feel still. The feeling is useful and real in the frame of your life. But you are also not separate from the greater motion. Your rest exists inside Earth's rotation. Earth's rotation exists inside its orbit. Earth's orbit exists inside the sun's galactic journey. The sun's journey exists inside a moving galaxy. The galaxy exists inside an expanding universe. Your stillness is nested inside motion. That is a more beautiful answer than simply saying everything moves. It means rest and motion are not enemies. Rest is local motion shared. Stillness is what movement feels like when everything nearby moves together. This also explains why we are not constantly overwhelmed by cosmic speeds. If our bodies had to feel every layer of motion, life would be impossible. Instead, we feel changes close to us. We feel acceleration, vibration, impact, pressure, balance. We do not feel the silent shared motion of Earth around the sun, because there is no nearby stationary object resisting us. The universe is moving us gently because we are part of the moving system. That is why the night can be peaceful, not because the cosmos is still, because its motions are vast, smooth, and shared. But the peace should not hide the truth. The idea of an absolute still place becomes weaker with every scale. The room is not the final frame. Earth is not the final frame. The sun is not the final frame. The Milky Way is not the final frame. Even the large-scale universe gives us expansion, not a perfect resting room. So is there any true still place? In the everyday sense, yes. A book can be still on a table. A person can be still in bed. A lake can be still under a windless sky. These are real experiences. But in the absolute cosmic sense, stillness becomes almost impossible to find. Not because we have failed to search far enough, but because the concept itself depends on comparison. Without a final universal object to compare against, stillness cannot become the simple absolute thing our intuition wants. The universe does not say, "This is at rest." It says, "This is moving relative to that." And that is enough to build physics. And this layered truth is exactly what the video has been building toward. The stillness you feel is not a lie. It is the smallest layer. The motion of Earth is the next layer. The orbit around the sun is the next. The sun's movement is the next. The Milky Way's movement is the next. Cosmic expansion is the largest layer we have reached. At every step, stillness survives locally, but disappears globally. That is the pattern. This also gives a new meaning to the phrase, "Nothing is ever still." It does not mean every object is shaking, crashing, or speeding visibly through space in a chaotic way. It means no object exists in a final state of absolute rest that applies to every frame. Everything belongs to relationships. Everything has motion relative to something. Everything is part of a larger system. Even calm objects are carried by large emotions. Even quiet places have cosmic paths. Even rest belongs to a moving universe. This is why the question feels so powerful for a space documentary. It begins with a feeling everyone understands: sitting still. Then, it reveals that the feeling depends on a narrow frame. The wider the view becomes, the more the stillness falls away. By the time we reach the expanding universe, stillness has become not a fact, but a perspective. And perspectives can change. When you sit in a room after understanding this, the room does not look different. The floor remains under you. The walls remain still. The world does not suddenly shake. But your idea of the room changes. It becomes a quiet compartment on a spinning planet, orbiting a moving star, inside a traveling galaxy, in an expanding universe. Nothing needs to visibly move for your understanding to move. That is the power of astronomy. It changes the meaning of what was already there. The question now becomes deeper than whether anything is still. We can ask why the universe is built this way in the first place. Why is motion so natural? Why do objects rotate, orbit, fall, drift, and gather? Why did the universe not settle into perfect rest? Why does reality seem to prefer movement, change, and structure? To answer that, we have to look at the forces and origins behind the motion. Gravity, energy, formation, conservation, the early universe, the birth of stars and planets, the way matter carries motion forward through time. Because motion is not just something objects happen to do. Motion is built into how the universe became what it is. And that is where the next part of the journey begins. Because motion is not just something that happens in the universe. Motion is part of how the universe became what it is. Planets do not orbit because they decided to move. Stars do not drift through galaxies by accident. Galaxies do not fall toward one another because the universe is poorly arranged. Motion is built into the history of matter, gravity, energy, and formation. It is not a small detail added later. It is one of the reasons structure exists at all. If we imagine a perfectly still universe, it is hard to make anything familiar from it. No spinning planets, no orbiting moons, no stars moving through galaxies, no gas clouds collapsing, no galaxies gathering into groups, no expansion of space across the largest scales. A universe with no motion would not be the universe we know. It would be a frozen idea, not a living cosmic history. The real universe began hot, dense, and changing. It was not born as a calm room full of finished objects. It expanded, it cooled. Matter formed. Tiny differences grew. Gravity began pulling slightly denser regions together. Gas moved. Clouds collapsed. Stars ignited. Galaxies formed. The universe became structured because matter did not simply sit perfectly still. Motion allowed the universe to become uneven, and unevenness allowed structure to grow. That is one of the deepest ideas in this story. If everything were perfectly smooth, perfectly balanced, and perfectly still, there would be no planets, no stars, no galaxies, and no place for life. Structure requires differences. Differences create gravity. Gravity creates motion. And motion creates new structure. The universe builds itself through movement. Gravity is one of the main reasons motion is everywhere. Gravity does not simply hold things down. It connects matter across distance. It pulls objects toward one another. It bends paths. It turns straight motion into orbit. It turns scattered gas into stars. It turns galaxies into groups and clusters. Where there is mass, there is gravity. Where there is gravity, motion becomes difficult to avoid. A cloud of gas in space may begin wide and cold, but if gravity starts to pull it inward, the cloud changes. It does not remain a still cloud forever. Parts of it move toward denser regions. Material falls inward. The cloud can spin, flatten, heat up, and eventually form a star. Around that forming star, leftover material can become a disk, and inside that disk, planets may grow. Motion is present at the birth of stars. Motion is present at the birth of planets. Motion is present before a world ever has a surface to stand on. This makes stillness feel even less fundamental. We are used to thinking of motion as something that happens to objects after they exist. A ball sits still, then someone kicks it. A car is parked, then someone starts it. A door is closed, then someone opens it. Everyday life often begins with objects at rest, then adds motion. But the cosmos is not like a room full of parked objects. Many things were born moving. Stars formed from moving gas, planets formed from orbiting disks, galaxies formed from matter flowing under gravity. The universe did not start with finished still objects waiting for motion. Motion was part of the making. Another reason motion persists is that space has very little friction compared with everyday environments. On Earth, moving things often slow down because they rub against air, water, ground, or other surfaces. A rolling ball eventually stops. A car stops if the engine stops pushing. A thrown object falls and hits the ground. In daily life, stillness feels natural because friction constantly removes visible motion. But space is different. There is no cosmic floor dragging planets to a halt. No thick air slowing Earth around the sun. No road under the moon. No table under the stars. In the near vacuum of space, motion can continue for an extremely long time. An object in motion does not need a constant push to keep moving. It keeps moving unless something changes that motion. Gravity can bend the path. Collisions can redirect it. Interactions can transfer energy. But motion itself does not simply disappear because the universe prefers stillness. This is one of the reasons orbits can last. Earth does not need fuel to keep moving around the sun. The moon does not need an engine to keep orbiting Earth. The planets do not need a hidden force pushing them forward every second. Their motion continues because of inertia, while gravity shapes the path. Motion continues, gravity curves it. Together, they make orbits. This combination is everywhere. It is why moons circle planets. It is why planets circle stars. It is why stars move in galaxies. It is why galaxies move in groups. The details change at each scale, but the deeper pattern remains. Objects carry motion, and gravity reshapes that motion into structure. The universe is not built from stillness interrupted by movement. It is built from movement organized by gravity. A dark nebula may look still, but inside it, gravity may be slowly gathering gas. A star may look steady, but inside it, nuclear fusion is transforming matter into energy. A planet may look peaceful, but it rotates, orbits, cools, heats, and changes. A galaxy may look frozen, but its stars are moving, its gas is shifting, and its history is unfolding. Stillness is usually only what change looks like, when the change is slow. This is important for the tone of the story. The universe is not constantly violent in a loud, chaotic way. Much of its motion is calm, steady, and almost invisible. But calm does not mean stopped. The most peaceful systems are still dynamic. Earth's orbit is calm. The moon's orbit is calm. The sun's journey through the galaxy is calm from our point of view. Cosmic expansion is silent. Motion can be gentle. Motion can be stable. Motion can be the reason peace exists. That may sound strange, but Earth itself proves it. A day exists because Earth rotates. A year exists because Earth orbits. Seasons exist because Earth moves around the sun while tilted. Tides are connected to the motion and gravity of the moon and sun. The rhythms of life are tied to motion at every level. Life does not happen on a still world. It happens on a world whose motion became rhythm. This is why the idea of a motionless Earth would not be more natural. It would be a different planet, a different sky, a different climate, a different history. Earth's motion is not an inconvenience that life has to ignore. It is woven into the conditions life learned to use. The same is true on larger scales. Stars are born from moving gas, galaxies grow through motion and interaction, new elements are scattered by explosions, material moves through space and becomes part of future stars and planets. The universe recycles itself through motion. A still universe would not be safer. It would be emptier. Motion also carries memory. The way an object moves can tell us where it came from and what happened to it. A planet's orbit contains clues about the solar system. A star's motion can reveal whether it belongs to a group, a stream, or an old galactic event. A galaxy's shape can show signs of past encounters. Even the expansion of the universe carries information about its history. Motion is not just movement. It is evidence. The cosmos records its past in paths, spins, orbits, and flows. This is why astronomers care so much about motion. A star's position is not enough. Its motion tells a deeper story. A galaxy's image is not enough. Its velocity and relationship to other galaxies reveal the larger environment. A planet's existence is not enough. Its orbit explains what kind of system it belongs to. To understand the universe, we have to understand how things move. Because motion is the universe remembering itself. This brings us back to the question of why nothing is ever still. Part of the answer is that the universe has no reason to erase all motion. In everyday life, motion fades because friction and collisions convert organized motion into heat. But in space, many objects keep moving for enormous lengths of time. And when motion does change, it often becomes another kind of motion. Another orbit, another fall, another flow. Motion transforms. It does not simply vanish into perfect rest. Even when objects collide or merge, the result is not usually final stillness. Two galaxies can merge and form a larger galaxy, but the stars inside continue moving. Gas clouds can collide and form stars, but the stars rotate and move. Material can fall into a black hole, but the surrounding disk can spin violently. Gravity can gather matter, but the gathered matter still has motion. The universe rearranges motion. It does not easily delete it. This is connected to conservation laws, but we do not need complicated equations to feel the idea. The universe keeps track of things. Motion, rotation, energy, and momentum are not casually erased. They can be transferred, shared, redirected, or transformed. But they do not simply disappear because an object enters space. The past leaves motion behind. That is why a forming star can spin, why a planet can orbit, why a galaxy can rotate, why ancient motion can survive into the present. The universe carries forward what came before. This also explains why perfect stillness is so hard to imagine physically. To make something truly still, we would need to define still relative to all possible frames, remove its inherited motion, remove gravitational influence, remove expansion, remove interaction, and place it outside every relationship. But that would not describe a real object in the universe. Real objects exist in systems. They have histories. They are affected by other things. To exist in the universe is to belong to relationships, and relationships create motion. This is the simple version of a deep truth. Nothing is completely alone. A planet belongs to a star belongs to a galaxy belongs to a larger structure. Even light traveling through emptiness belongs to the geometry and expansion of space. Everything has context, and context means change. Motion is also built into the arrow of time. The universe does not simply sit as one unchanging picture. It has a past and a future. Stars form, live, and die. Planets cool. Galaxies evolve. Space expands. The fact that we can tell a story at all means the universe changes. And where there is change, there is some form of motion, transfer, or transformation. A completely still universe would have no story, no before, no after, no journey. But the real universe is a journey. That is why a space documentary can follow it from a quiet room all the way to expanding space. The path is not forced. It is natural. Every scale reveals another kind of motion, because motion is woven into every scale. Human rest is nested inside planetary rotation. Planetary rotation is nested inside orbit. Orbit is nested inside galactic travel. Galactic travel is nested inside cosmic expansion. The pattern repeats because reality is layered, and every layer moves. This is what makes the question beautiful, instead of only frightening. Nothing is ever still, because everything belongs. Everything is connected by origin, gravity, motion, energy, or space itself. The universe is not a set of isolated objects waiting in silence. It is a connected, evolving system. Its stillness is local. Its motion is universal. And once we understand that, the final question becomes clearer. If motion is built into reality, if every object belongs to a larger moving frame, and if even space itself expands, then perhaps the universe has no final still center at all. Not Earth, not the Sun, not the Milky Way, not any one galaxy, not any one point. Only perspectives inside a larger motion. That idea leads into the final part of the journey, because after following motion from your quiet room to the largest scales of the cosmos, we can finally return to the original feeling and see it differently. The feeling of stillness is not wrong, it is just incomplete. And the universe is far larger, stranger, and more restless than that feeling ever allowed us to imagine. After following motion from the floor beneath you to the edge of cosmic expansion, the final idea becomes clear. The universe has no simple, still center. Not Earth, not the Sun, not the Milky Way, not one galaxy hidden somewhere in the distance, not one perfect point where everything finally stops. Every time humans thought they had found the center, the universe became larger. Earth felt central because the ground felt stable and the sky seemed to move around us. Then, Earth became a rotating planet. The Sun felt central because it controlled the solar system. Then, the Sun became one moving star inside a galaxy. The Milky Way once seemed like the whole universe. Then, it became one galaxy among countless others. At every step, the fixed background moved. At every step, the center became smaller. And at every step, stillness became more local. This does not mean nothing has structure. The universe is not meaningless chaos. Earth really is the center of your local experience. The Sun really is the center of the solar system in the way that matters for planets. The Milky Way really is our galaxy, but none of those centers are final. They are centers inside systems, not the center of all reality. That is the difference. A local center can exist. An absolute center is something much harder. The universe gives us many homes, many reference points, and many useful frames. But it does not seem to give us one final resting place, where all motion disappears. Instead, it gives us layers. A person rests in a room. The room turns with Earth. Earth falls around the Sun. The Sun moves through the Milky Way. The Milky Way moves with other galaxies. And on the largest scales, space itself expands. There is no final floor beneath all of it. Only deeper frames, only wider views, only motion inside motion. This is why the question matters so much. Why is nothing in the universe ever still? Is not just about speed. It is about perspective. It asks whether the feeling of rest we trust every day can survive when we zoom out far enough. And the answer is strange. Rest survives locally, but not absolutely. You can be still in bed, but not still compared with Earth's rotation. You can be still on Earth, but not still compared with the Sun. Earth can follow a stable orbit, but the Sun is moving through the galaxy. The galaxy can hold its stars, but it is moving inside a larger gravitational environment. And beyond that, the universe itself is changing. Stillness keeps returning in small frames, then disappearing in larger ones. This is not a failure of the word still. It is how the universe works. Stillness is useful because life happens locally. Without local stillness, we could not build, sleep, measure, or think clearly. A house must be still relative to the ground. A cup must be still relative to a table. A person must be able to rest relative to a bed. Local stillness is real. But it is not the whole story. The whole story is that every local rest is carried by a larger motion. That may be the most beautiful way to understand it. You are not wrong when you feel still. You are feeling the motion that everything near you shares. The room does not slide because it moves with Earth. The air does not rush away because it moves with Earth. Your body does not feel the orbit because you travel with the planet. Stillness is the feeling of belonging to the same moving system. It is not the absence of motion, it is shared motion made quiet. This idea turns the ordinary world into something cosmic. A silent room is not truly separate from the universe. It is a small, calm pocket inside layers of movement. The floor beneath you is part of a spinning planet. The planet is part of an orbiting system. The system is part of a moving star. The star is part of a moving galaxy. The galaxy is part of a larger cosmic story. The room is quiet, but its address is moving. Every address in the universe is like that. A planet is not just a place. it is a path. A star is not just a light, it is a traveler. A galaxy is not just a collection of stars. It is a moving structure shaped by gravity and time. Even the space between distant galaxies is not a dead background. It changes as the universe expands. Everything has a history. Everything has a direction, a relationship, or a transformation. Everything belongs to change. This is why the universe has no still center in the simple human sense. A center usually means a fixed place around which everything else is arranged. But the cosmos does not behave like a room with a middle. It behaves like a vast evolving system, where centers exist inside smaller systems, but the whole does not give us one obvious throne. Earth is central to life on Earth. The Sun is central to the solar system. The Milky Way is central to our galactic home. But the universe is not built around any one of them. This can feel unsettling because human beings naturally want a place to stand. We want a foundation. We want a final map with a red dot that says you are here. Astronomy gives us the red dot, but then it keeps zooming out. Each wider map shows that our red dot is moving inside another map, and that map is moving too. You are here, but here is traveling. That is the haunting truth. Your location is not a fixed point. It is a moving relationship between Earth, Sun, galaxy, and universe. The place where you sit right now will never be repeated in the exact same cosmic way. Earth rotates onward. Earth continues around the Sun. The Sun continues through the Milky Way. The galaxy continues through larger space. The universe continues to evolve. Even if the room looks the same tomorrow, the cosmic situation has changed. We return to familiar moments, but never to the exact same universe. This makes time feel different. A day is not simply a number on a clock. It is Earth turning. A year is not just a calendar. It is a journey around the Sun. A lifetime is not just years passing. It is a small part of Earth's path, the Sun's path, and the galaxy's path. Time and motion are tied together in the way we experience the universe. We measure change because the universe changes. We remember because things do not stay fixed. We exist in motion. The final center we might hope for is not a place, but maybe a perspective. The understanding that there is no final still place. Once we accept that, the universe becomes less confusing. We stop trying to find the one object that does not move, and instead we ask how each object moves relative to others. We stop imagining a cosmic flaw and start seeing a network of relationships. That is where the beauty is. A moon belongs to a planet belongs to a star belongs to a galaxy belongs to a larger structure, and all of it belongs to the history of the universe. Motion is the language of those relationships. Without motion, the moon would not orbit. Earth would not have a year. Stars would not travel through galaxies. Galaxies would not gather, merge, or form the cosmic web. Space would not carry light across a changing universe. The story would stop before it began. But the story did not stop. It continued. It became stars. It became galaxies. It became planets. It became oceans. It became life looking back at the motion that carries it. This is why the question has an emotional answer as well as a scientific one. Nothing is ever still because the universe is not a finished statue. It is an unfolding process. It is not a frozen picture. It is a history still happening. Every object we see is part of that history, and every object carries motion from what came before. The solar system carries the memory of the cloud that formed it. Earth carries the rhythm of spin and orbit. The Milky Way carries the motion of its stars and past encounters. Distant galaxies carry the evidence of expansion. Even light carries history as it crosses space. Motion is not separate from the universe. Motion is one of the ways the universe remembers itself. So when you feel still, You are touching only the smallest layer of the truth. You are feeling what it is like to move together with your local world. You are feeling the calm of shared motion. And that calm is real. It matters. It is the reason Earth can feel like home. But home is not motionless. Home is moving with you. This may be the most important final reframe. The universe does not take stillness away from us completely. It changes what stillness means. Instead of being absolute rest, stillness becomes belonging. A person rests because the bed, the room, the air, and the planet move together. Earth is home because we share its motion. The solar system is home because Earth shares the sun's motion. The galaxy is home because the sun belongs to it. Stillness is not being outside motion. Stillness is being carried by the same motion. That is why we do not feel thrown through space. We are not separate passengers watching the universe move around us from the outside. We are part of the moving system. The motion does not appear as motion because it is woven into everything near us. The universe carries us gently enough that we call it still. But the truth remains. You are on a spinning planet. That planet is falling around the sun. The sun is carrying the solar system through the Milky Way. The Milky Way is moving among galaxies, and the largest distances of the universe are changing with time. There is no final pause, no perfect cosmic rest, no still center waiting beyond the last star. Only motion, relationship, and scale. And in a strange way, that makes the universe feel more alive. Not alive like an animal, not conscious, not purposeful in a human sense, but alive with process. It has movement, it has formation, it has collapse, orbit, expansion, and transformation. It has no need to freeze in order to be beautiful. A still universe would be silent in the deepest way. No sunrise, no seasons, no stars forming, no galaxies changing, no light crossing space, no story. But this universe moves, and because it moves, it creates the conditions for everything we know. The sunrise is motion, the night sky is motion, the year is motion, the galaxy is motion. Even your quietest moment is carried by motion. That does not make peace impossible, it makes peace more mysterious. A person can lie quietly under a night sky while moving through space at many scales at once. A child can sleep on a planet in orbit. A forest can stand still relative to the ground while Earth turns beneath the stars. The calm exists, but it exists inside motion. That is the real wonder. Not that stillness is false, but that stillness can exist locally inside a restless universe. The final answer, then, is not that nothing ever stops because the universe is chaotic. It is that the universe is relational. Everything exists with respect to something else. Everything is measured from some frame. Everything belongs to systems larger than itself, and those systems are moving, evolving, and changing through time. Stillness is local, motion is cosmic, and we live between the two. This is the feeling the video should leave behind. The next time you sit in a quiet room, nothing around you needs to change. The walls can remain still. The floor can feel solid. The night outside can be silent. But somewhere in your mind, the scale can open. The room becomes part of Earth. Earth becomes part of the solar system. The solar system becomes part of the Milky Way. The Milky Way becomes part of the expanding universe. And suddenly, stillness is no longer simple. It becomes one of the strangest feelings in existence. Because to feel still is to forget, for a moment, how much motion is carrying you. And to understand the universe is to remember. You are not standing on a fixed platform. You are not living under a frozen sky. You are not watching the cosmos from outside. You are inside the motion. Every second, every breath, every night. Earth turns, Earth falls, the sun travels, The galaxy moves, space expands, and you are carried with all of it. That is why nothing in the universe is ever truly still. Thank you for watching this journey through the hidden motion of everything around us. If you enjoyed this calm exploration of space, time, and the moving universe, subscribe to the channel for more space documentaries like this. Leave a like if you want more long journeys through the deepest questions in astronomy, and write in the comments what impossible space mystery you want to explore next. Tonight, you are watching the Space for Sleep channel, talking about why is nothing in the universe ever still. Sleep well and keep looking up. Good night.